All right, students, we're going to be looking now at markdowns. And so there's a couple of formulas that you might want to be aware of when it comes to markdowns. Of course, markdowns deal with a couple of different factors. So now when you're dealing with markdowns, you're starting with your selling price as the 100%, because you're going to be marking it down from the 100%. So 100% is your selling price. And then, of course, whatever you mark it down, whatever percentage that ends up being, is a mark down amount. And so those are the kind of things that we're going to be figuring with these particular problems, and what Sienna is going to be dealing with. You do have a couple of these or one of these in your check-in assignment. But this formula here is the first one. Original selling price equals the sales price minus or divided by the markdown percent. And so that's very similar. So I kind of wrote it this way, this new formula. It's very similar, but this one has sales price up here, and then it has your original price, which is kind of similar to your cost. And then again, it still uses the 1 minus the rate. And again, the sales price is the higher amount, and the original price is typically it's going to be the lower amount because you put it on sale. So this is kind of like going on sale formula, I guess you'd say, on sale. I'll call it on sale. You're lowering the price. So your original price is going to be higher than your sales price. Your sales price is going to include a discounted amount, and that's what we're going to be looking at. So let's look at the first problem here. I think it'll make more sense. Is the original price of a backpack at Walmart is currently on sale for $99, and that's the sales price, right? It's on sale. That's the key. So that's going to go here with this formula, and then they want to know it's a 25% markdown. So we're going to divide those two together. And that's going to give us what our original price was before we put it on sale.
$132.
It was $132 before we put it on sale. So that's what I originally had it for. That was originally my sale price, my normal sale price. But then I put it on sale. So I marked it down to $99. And I came out with the $132 was my original price. If I want to find out how much of a discount that was, of course, I can simply subtract the 132, the 99 from the 132, and that would give me how much of a discount dollar-wise I had. And you can also use a formula for that, but I'm already probably confusing you with all these different formulas.
$33.
Yeah, so it's a $33 discount that you got. And you could use the portion formula to figure that out. All right, so then this one's the same, very similar to that problem. I think I have two of each. What is the original selling price of a necklace currently on sale? So again, sale price is $79. And that includes a 35% markdown. So 1 minus 0.35 equals 0.65. So I'm going to divide those two, and that's going to give me my original price. So what's that one?
121.54.
So $121.54 was what I originally priced it for, but I marked it down by 35%. So therefore, my sale price is $79. So I'm going backwards on these ones, but this is kind of how you figure markdowns. Again, you can do it the other way around. You can go, I want to do, my original price was 121. I want a 35% markdown on it. And so therefore I'm going to do it. And I want to know what the sale price is. If I just want to do the markdown, I wouldn't include the one. I would just do this times 35, and that would give me my markdown. But because I want to get the sale price, I want to add that back in. So I would need to minus it from 1 to get my net price, which is 65. So this is very similar to what I was calling before the list and net price formula. It's the same exact formula if you just want to find the net price versus the list price. And kind of the same thing. My list price was 124. If I do the 1 minus the rate I want to get to mark down, that would give me 65. I'd multiply those together, and that would give me my net price. It's the same formula that we looked at before, just using different terminology. So when you're doing markdowns and they're looking for your original selling price, this is the way you would do it. If they're looking for the sale price, you would just do it the opposite direction, take the original price, multiply it by 1 minus the rate, which would be 0.65. That would give you your sale price or your net price. All right. This gets funner as we go here. Hold on to your seat. So we're going to move on to a series of markups and markdowns. And this is where it becomes fun. So sorry. I don't know why this thing is way down here. All right, so now we have a series of markups and markdowns, and this happens a lot. Like, for instance, you might be, having an item that, isn't moving. You thought, I'm going to do a sale price, or I'm going to do a sale price on it because I want, or originally I put it, I added a markup to it and it ain't selling. So I want to lower the price a little bit, see if maybe people come in or buy it. So in this case, maybe Sienna has a treadmill or a squat rack and she bought it for this much and she marked it up, and then nobody's coming to buy it. So she marks it down, decides that still isn't moving. So she marks it down even more, trying to get rid of it. And so that's kind of what a series of markups and markdowns would look like. And this is kind of putting it all together. So I'm just going to use the example here. In March, Women's Sport purchased a designer bathing suit for $50 each. And the original markup was 60% based on selling price. And the shop took a 25% markdown, having a sale after 3 weeks. In May, they did that. After 3 weeks, the sale was over and all merchandise was marked back up 15%. But by July, many of the bathing suits were still in stock. So the shop took a 30% markdown to stimulate sales. And at the end of August, the balance of bathing suits were put on clearance sale with a final markdown of another 25%. Compute the intermediate prices and the final selling price of the bathing suits. So they want to know the ultimate answer to all this. So we have to start with each thing one at a time. So to begin with, they bought each bathing suit for 50 cents or $50, excuse me. That was the original selling price, right? So I'm just going to do the formula down here and keep erasing it, if you don't mind. So the original price, that was what they bought them for. So that was the cost. And then the original markup was 60% based on selling price. So really, we're actually going to use, I should have put the other formula here, the cost, and then selling price, and then 1 minus the rate. That should have been what we used. So the cost was 50, and the original markup was 60% based on selling price. So it would have been the selling price formula. So that would be 1 minus the rate. So that would be 1 minus 0.60, which would be 0.40. And then that's going to tell us what the original selling price was. That's what we were selling them for. So want to do the math on that?
$125.
125?
Yeah.
Okay, so the original selling price of the bathing suits was $125. And I'm going to just double check because I want to make sure that I'm following this the right way. Yep, so $125 was the original selling price. So that would go here. All right, I'm going to erase some of this just so I can work the next set of the problem. So $125 was their selling price. And then they decided in May to do a markdown on that selling price. So there's two ways we could do it. The markdown was 25%. So we could, again, just use the 125 times point. What did it say, 25%? So we could just do that. That's using the old-fashioned portion formula. We're just going to try and find out what is the markup. What is a 25% markdown? So what is it? What's 125 times 0.25? It is
31.25.
It should be 93.
75. That's the.
That would be the. So what was the markup? Sorry, I got ahead of myself. What was
31.25.
31.25?
Yeah, $31.25.
Okay. So that gave me my discounted amount, or my markdown, right? That's my markdown amount. So I could just subtract that, from the 125, and I'll know what my new retail, but this is just asking you, what is the markdown? So we're going to put 31.25, right? But just for fun, we want to make sure that we get it correct. So it comes out, if you take the 125 minus the 31.25, that means the new selling price is 93.
75.
75, right? All right. Now, just for fun, just to, to make this more fun, because I know you guys are just thoroughly enjoying this. I'm going to I'm going to redraw that same formula using the selling price formula that's here, or actually no, the cost plus formula, because we're going to add the markdown. So hold on. I could have also done it this way where I did 125. Oh, it's the markdown. Yeah, 1 minus point. So this would be this formula here. 1 minus 0.25, which would be 0.75. And if I just multiplied those together, it would have gave me the 93.75. That's just a faster way to do it. And that gives me the sales price. So that was basically using this formula. I haven't used it yet, but there it is. All right, sorry if that confused you. Let's move on to the rest of the question. Then it says calculate. So then the sale came to an end and they wanted to go ahead and mark it up 15% based off the previous selling price of 93.75. So 93.75 times, it could be times 15, which is, again, I'll just do it this way. Original price is 93.75. I'm going to multiply it by 0.15. That'll give me the amount of markup. Or
$14.06.
Or I could just do the 1 plus 1.15. That adds the 93 back in, and that would give me my selling price. So what does it come out to?
14.06 was the markup.
And then what is it? If I take 93 by 1 plus 1.15, what does that come out to?
That's 107.81.
So $107. So now my new price is $107.81. That's how much I'm selling my bathing suits for. However, things are really slow. And July rolls around and you know what? They're just not selling. We're getting near the middle of summer. People aren't buying bathing suits like they were. So now I want to go ahead and I want to mark it down by another 30%. So again, I could just simply multiply the 107 by 30. And that would give me the markdown amount. Or I could also do it by the complement 1 minus 0.30, which is 0.70. And I could take 107.81 times it by 0.70, and that would give me my new
$75.47.
Yeah, so what is it?
$75.47.
So that's, again, this is using this formula here. So 75.47. And then the last thing is if they're still not selling, so I'm going to do an additional 25%. So again, 1 minus 0.25 is 0.75. So what is the final selling price?
56.60.
So I'm selling them for $56.60. So that's ultimately my answer. And it says round to the nearest cent. So I basically just use this, other than the first one, I just use this, ultimately I just use this formula here to do it. I use the original price and the sales amount and then the rate, and I was able to solve all this all the way down. So, all right, one final thing, and I did not look at this at all. I just cut and pasted it, but I want to cover it, and it's perishables. I might make it as a separate video. So, but no, I won't, because I didn't really have a category for it. So let me go back to here. And this one, I'm kind of cheating because I'm going to use what's out of the book, but. All right, last section here is 8:12 on chapter 8. And this is selling price of perishable goods. And unfortunately, what happens when you're working with perishables, and I have one question on this, by the way, in the check-in assignment this week, and Sienna has a smoothie bar. And unfortunately, some of the fruit that she bought for her smoothie bar has went bad. And that is a loss, right? And so when you have a loss like that, because of a perishable item, you want to try and recoup some of that cost in the overall money that you'll make in selling smoothies. So she doesn't want to just lose that. She wants to be able to recoup that. And so she needs to adjust the price of her smoothies to accommodate for a certain percentage of loss. And by the way, many restaurants do this. They price, you're not just paying for the price of a meal, you're also paying for the price of some perishable goods that have perished, and they have to be able to pass that cost on. So many times the prices of their menu items are to cover some of the cost of perishables. And so that happens quite often in business. And it's very important to know how to calculate that, because it's not just as simple as going, okay, here's my total earnings and then just deduct that amount or whatever, or just add that amount. You want to figure out exactly how much each item needs to be calculated. And here in your book, there's some steps on doing that. There's step 1, which is to find the total expected selling price, found by applying the selling price formula, which is what we already looked at. And then it's step 2, find the anticipated spoilage. So to find the amount of anticipated spoilage, use this formula, which is right here. And then thirdly, calculate the selling price of the perishables. So we'll kind of follow that through with this enchanted group, whatever it's called here. Let me see, I'm going to just go to the answers so that way, because I told you I didn't really look at this one. It's been a while since I've worked it out, and I kind of ran out of time to go through it effectively, but I do want to at least kind of slowly work through this with you. So let me see if I can find it. Here it is. No, okay. Perishables. There we go. Okay. So a chain of flower shop purchased 800 dozen roses. So I'm just going to write these down. 800 dozen roses. And that's a dozen, so times 12. Each 800 is times 12. Valentine's Day at a cost for $6.50 per dozen. And they have a 10% spoilage rate. All this will become valuable in a minute. And then they hope, what price per dozen should the roses be sold to achieve a 60% markup based on selling price? So the first thing they want you to figure out is the selling price total. So you don't take the spoilage out yet. Most people attempt to take it out at the beginning. You first want to find out how much do you hope to sell them all for, right? So we want to find out how much we want to sell them for. So again, they cost $6.50 per dozen. So we're going to do it all by dozen. Sorry. So we'll just do this formula. $6.50. And they want a 60% markup based on selling price. So again, this should have been here, $6.50, because we're trying to find selling price.
Professor, shouldn't the total cost be 800 into 6.5, which is 5,200? That's the actual cost. 800 dozen roses at a cost of $6.50 per dozen. So
let me see. Sorry.
that
Yeah,
should be the
you are
final
correct.
cost.
Sorry, I was going to do it by individual dozen, but you're doing it by the total, and you're right. You have to do it by the total. So, okay, so 52. Sorry. Thank you for holding me to task on this. Like I said, I didn't really work it out. So 5,200, right? Are you with me now? All right.
Yeah, correct.
And we're trying to find the total cost, excuse me, the total selling price. That was cost 52. I hate this. Okay, that was cost. Sorry, rate is 1 minus 60. And then we're trying to find the selling price. Remember, we're using the selling price formula. Cost, selling price, 1 minus rate. Right? So that's what we're trying to do first. We're trying to solve for that. So we're going to divide the 5,200 by 0.40.
13,000.
Okay, so 13,000 is how much I could sell them for. That is the amount. So let's write that here. That's the total amount. However, I'm going to have some spoilage on that. So anticipated spoilage is this formula right here. So total quality, the total quantity, so is 800 was my quantity, dozen. And I'm going to lose, what did they say? A 10% rate.
10%.
So I'm going to multiply that by 0.10 is 80, right? So I'm going to lose 80. And then I need to do I need to do this formula up here. So I'm going to follow that formula. Expected total selling price is 13,000 divided by total quantity 800 minus 80. So what does that come out to?
$18.06 per dozen.
Okay.
It should be a new selling price.
Right. That's our new selling price right there. $18 is how much I should sell them for. And that's so that I can recoup the 80 that I'll lose, 80 dozen that I'll lose. So that's your answer to this problem. And it's kind of worked out here for this other problem here, if you want to look a little bit more in detail at that. So, all right, well, that's it for chapter 8. Any questions as we end chapter 8?